Here are 10 weather stories you can listen to in English. Now, let's get started. Space Weather Watcher. Can a satellite 35,800 kilometers away see a park in your city? Japan's Himawari 9 weather satellite can see something almost that small. This satellite watches our planet from about 35,800 kilometers up in space. Its camera is so strong that it can identify objects on the ground that are just 500 meters wide. This helps weather forecasters see the small movements of clouds in great detail. It works 24 hours a day and sends new data of the entire Earth every 10 minutes. This satellite does more than just take regular pictures. Himawari 9 uses 16 different types of light, including visible and infrared light, to get information. This special ability allows it to check many things from space. For example, it can see the different types of clouds and measure their height. It also checks the temperature of the sea surface and can find smoke from volcanoes. This data is very important for making better weather forecasts and warning people about disasters. AI Weather Forecast. Can an AI predict the weather for the next 10 days faster than a supercomputer? Google developed an AI named GraphCast that can do this. This AI learned from 40 years of past weather data. It is now able to forecast the weather for 10 days into the future with high accuracy. This new technology is also faster than traditional supercomputer calculations. Traditional weather forecasting uses supercomputers to solve complex physics equations. This method needs a lot of power and time. However, AI learns the relationships between weather patterns directly from huge amounts of data. This different approach is expected to reduce the calculation cost to less than 1/1000th. Hottest place on Earth. Where is the hottest place on our planet? The answer is Death Valley in the United States. On July 10, 1913, the temperature there reached 56.7 degrees Celsius. This is the highest temperature ever recorded on Earth. Death Valley is a desert, and it is famous for its very hot and dry weather. For many years, people thought a different place held the world record. A temperature of 58 degrees Celsius was recorded in Libya. However, the World Meteorological Organization, WMO, investigated this old record. In 2012, they decided that the measurement in Libya was a mistake. After this decision, Death Valley's record of 56.7 degrees Celsius was officially recognized as the world's hottest temperature. Strongest wind record. Do you think the strongest winds are caused by hurricanes or typhoons? The world record for the fastest wind speed was actually set by a tropical cyclone. In 1996, Cyclone Olivia hit an island in Australia. An automatic weather station on Barrow Island measured an incredible wind gust of 408 kilometers per hour. This is about 113 meters per second. The World Meteorological Organization, WMO, confirmed this measurement, making it the official record for the fastest surface wind ever recorded. However, this record does not include winds from tornadoes. Tornadoes can create even stronger winds, but measuring them is extremely difficult. The powerful force of a tornado often destroys weather instruments before they can record the highest speeds. For this reason, scientists cannot always get exact data from inside a tornado. Therefore, the wind from Cyclone Olivia is recognized as the official world record for a non-tornadic wind. Butterfly effect. Can a butterfly flapping its wings in Brazil really cause a tornado in Texas? This question is the starting point of something called chaos theory. The idea is known as the butterfly effect. It means that a very small change at the beginning can cause a very big difference later on. Because of this, it is very difficult to make accurate long-term weather forecasts. A tiny error in the initial data can grow much larger over time and change the entire result of the prediction. To solve this problem of initial errors, weather forecasters use a method called ensemble forecasting. With this method, they run many computer calculations for the same forecast, not just one. Each calculation starts with slightly different conditions. For example, one might start with a slightly higher temperature and another with a little less wind. By looking at all these results, forecasters can judge how probable the forecast is. This allows them to see the most likely weather pattern. Inside thundercloud? Did you know that inside a summer thundercloud, the wind can blow upwards faster than 40 meters per second? This powerful cloud, also known as a cumulonimbus, has very strong air currents swirling inside. The upward wind, or updraft, can be faster than 40 meters per second, while the downward wind, or downdraft, is over 15 meters per second. This strong air movement creates lightning and hail. The updraft carries water droplets and small ice crystals high up. They bump into each other and create static electricity, which causes lightning. These strong winds also explain how large hail is made. A small piece of ice is carried up by the updraft and collects more water, which freezes. Then it becomes heavy and starts to fall. However, the strong updraft can catch it and lift it up again. This cycle of rising and falling can happen many times. Each time, the piece of ice gets a new layer and grows bigger. This is how large, damaging hailstones can form inside a thundercloud. Supercomputer Weather Forecast. How can we know the weather for next week? Scientists use supercomputers and divide the Earth into tens of thousands of small boxes. A supercomputer calculates what will happen in each box just 10 seconds later. By repeating this calculation many times, it can predict the future weather. For example, the Japanese supercomputer Fugaku can finish this calculation in about 10 minutes. This helps us know the weather for a week ahead with high accuracy. This method is called numerical weather prediction. This prediction method is not magic. It is based on the laws of science, like how air and heat move. The Japan Meteorological Agency started using the Fugaku supercomputer in 2023. Thanks to this powerful computer, weather forecasts have become better. For example, the forecasts for the paths of typhoons are now more accurate than before. This helps people prepare for dangerous weather. Heavy floating cloud. Did you know that a floating cloud can be as heavy as 100 elephants? A normal cumulus cloud, the kind that looks like white cotton, weighs about 500 tons. This is the total weight of millions of tiny water droplets. Each water droplet is very small, only about 0.02 millimeters wide. All these small drops together make the cloud very heavy. So why doesn't such a heavy cloud fall down? It is because the water drops are very light and small. Warm air from the ground moves up and pushes the drops, keeping them in the sky. This upward air movement is called an updraft. If all the water in a cloud that is 1 cubic kilometer in size came down as rain, it would be 500,000 liters of water. Raindrop Speed Limit. Did you know that rain could hit the ground like a bullet? When a raindrop falls, it doesn't get faster forever. This is because of a force from the air called air resistance. Gravity pulls the raindrop down, but air resistance pushes it up. When these two forces become balanced, the raindrop stops getting faster. For a raindrop with a diameter of 2 millimeters, this final speed is about 23 kilometers per hour. Without air resistance, the story would be very different. If there was no air, the same raindrop could reach a speed of over 600 kilometers per hour before it hits the ground. This is incredibly fast and would be like a real bullet. Rain falling at that speed would be very dangerous for people and buildings. So we are very lucky that the air slows the raindrops down and protects us. 2 airplane clouds. Did you know that some clouds made by airplanes can tell you about tomorrow's weather? These clouds are called contrails. There are 2 types. The first type is made from an airplane's engine. The engine releases hot water vapor, and in the very cold air high in the sky, this vapor freezes into tiny ice crystals, making a long white line. The second type is made by the wings. The tips of the wings can cause a change in air pressure. This change quickly cools the air and a cloud can form. These 2 types of clouds tell us different things. A contrail from an engine that stays in the sky for a long time means the air is very wet. When the humidity is close to 100%, the ice crystals don't disappear. This is often a sign that the weather will get worse and rain may be coming. However, the cloud made by the wings disappears almost right away. So, if you see a contrail that stays for a long time, the weather might be changing soon.